Come to the exercise. Read the first Roman. Express each number as a product of its prime factors. That means already we learned a fundamental theorem on arithmetic. That means every composite number can be written as product of primes. Now they asked express each number as product of prime factors. Means some prime numbers product we are going to write. First one is 140. By prime factorization, every number can be written as a product of primes. 270, sir. 235, sir. 57, sir. So, 140 can be written as 2 square into 5 into 7. Now the next one. Second one. In the first Roman. 156. 2 table. 2 sevens are 14. 1 is remain. 2 eights are 2 threes are 6. 1 is remain 9 times. 3 13s are. So 156 can be written as 2 square into 3 into 13. Now let us see the next one. 3825. 5 table because there is 1's place 5. 5 sevens are 35. 3 is remained. 5 6 are 30. 2 is remained. 5 5s are. Again 1's place there is 5. Take 5. 5 1s are 5. 2. 5 5s are 25. 5 3s are. Now 3 table. 3 5s are 3 1s are. Now 3 table. 3 1s are 3. 7 is remained. So until you get a prime number you have to factorize. We got 17 here. Now 3825 can be written as 5 power 2, 3 power 2 into 17. Now let us see the next question. Fourth one. 5005. Take 5 because there is a 5 in its place. 5 ones are 001. Now take 11. 11 nines are 99. 1 is remained. 11 ones are 7 table. 7 ones are 7. 2 is remained. 7 threes are. Until you get a prime number, 13 is a prime number. So 5005 can be written as 5 into 11 into 17 into 13. Let us see the fifth question. 7429. Take 17 table. 17 fours are 68. How much is remain? 6. 17 fours are 68. So we have to take 17 threes are. 17 threes are 51. 1 1. That means 119. 17 sevens are. Now again 19 table. 19 twos are 38. 5 is remain. 19 threes are. Until you get a prime number. So 7429 can be written as 17 into 19 into 23. So the first Roman is completed. Let us come to the second Roman. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of two numbers. So first we are going to calculate LCM and HCF. Later we are going to check the relation between them. Now see the second Roman. 26 and 91. First 26 prime factorize 2 13 times. 91 17 7 table. 7 ones are 7, 2 is remained, 7 threes are. So 26 can be written as 2 into 13. 91 can be written as 7 into 13. Now HCF means highest common factor. What is common? 13. 13 is the highest common factor. Now let us see the LCM. 26 can be written as 2 into 13, 91 can be written as 7 into 13. Now first common and the remaining, because this is LCM, that means multiple. There we calculated the factor. So 13 into 2 into 7. 13 2s are 26, 26 7s are 26 7s are 7 2s are 14, 182. So we calculated LCM and HCF. Now we are going to calculate the relation. We are going to verify the verification between LCM and HCF and the numbers between them. LCM into HCF is equal to A into B. That means product of two numbers. 13 into 182 is equal to 26 into 91. You have to multiply 13 into 182. If you do the multiplication, 2366. Now 26 into 91. Do the multiplication. 2366. The both LHS and RHS is equal. So it's verified. So the relation is verified. Relation between LCM and HCF is equal to product of two numbers. Now let us see the second question in the second Roman. As usual, 510 and 92. By the prime factorization, we are going to calculate HCF and LCM of 510 and 92. Let us do it. Now let us see the second question in the second Roman. 510 and 92. 510, 2 table. 2 5s are 10, 2 5s are 10. 5 table. 5 5s are 5 1s are. 3 table. 3 1s are 3, 3 17s are. Now 92. 2 table. 2 4s are 8, 2 6 are. 2 23s. So 510 can be written as 2 into 5 into 3 into 17. 92 can be written as 2 into 2 into 23. Now we are going to calculate HCF. Common factor. What is the common factor? 2. Only 2 is the common factor. Now let us see the LCM. Now what is the common factor? 2. And what are the remaining? 2, 5 into 3 into 17 into 2 into 23. This all can be multiplied. 23,460. Now we are going to verify the relation. LCM into HCF is equal to A into B. Now substitute. 23,460 into 2 equal to 510 into 92. 46,920. This side also same answer. 46,920. It is verified. LHS equal to RHS. In the same way, see the third problem. 336, comma 54. Now come to 336. 2 table. 2 16s are 32. 1 is remain. 2 8s are. Now only prime number can be taken. Don't take 8 or something. 2 8s are. 2 4s are. Again 2. And come to 54. 2 2s are 4. 1 is remain. 3 9s are. 3 3s are. So Verify the relation. LCM into HCF is equal to A into B. So now first calculate the LCM. 336 can be written as 2 into 2 into 2 into 2, one more 2 is here, 7 into 3. 54 can be written as 2 into 3 into 3 into 3. Now 1 2 is common, 1 3 is common. So is there any common? No. So 2 into 3. HCF this is. HCF is 2 into 3, 6. Now come to the LCM. First take the common as 2 into 3. The remaining also should multiply. How many 2's? 3 2's. That means 8. And the remaining 7. And the remaining 2 3's. That is 9. Now multiply 2 into 3 into 8 into 7 into 9. 2 3's are 6. 6 8's are 48. 3024. Now we are going to substitute. LCM is 3024 and HCF is 6. That is product of two numbers. 336 into 54. Now the result, multiply these both and these both. We can get 18,144 and the right side also 18,144. It's verified the both. LHS is equal to RHS.